Hi boys and girls, today we'll be doing our solving for x introduction. So I've gone on to chapter 7. It's within the section called patterns, functions and algebra. So our previous topic discussed was algebraic expressions, and with algebraic expressions we learned all these rules that you were tested on through your assignment, and all these rules pertaining to our coefficient, our variable, our exponent, and constant. And what we do now at this stage is we no longer work with merely an expression, but we start working with solving an equation. Now, the importance of solving equations is we have a distinction between a left-hand side and a right-hand side. So with our previous chapter, when we worked with expressions, we were not required to solve anything. We were only asked to simplify expressions based on whether the terms were like or unlike. And I'm going to remind you of the separation technique that we applied so that we can clearly see where our different terms are. Now let's look at what is my coefficient. My coefficient of x squared, exactly, x squared. That coefficient is a -2. And then x would be my variable, and in this case I have an exponent there. But what is my coefficient of x? Here I would say it is 3, positive 3. What is my constant? In this expression above, the constant is 5. So we need to be very careful so that we can also work effectively and accurately with the signs. But when we look at our next chapter, we are using the laws, the theory, the application that we learned in the previous chapter with expressions to help us solve. So whenever we see the word solve, we will use an equal sign. So what I have on that side is my left-hand side, and what I have on that side is my right-hand side. So I'm going to draw a little scale here. Let's draw one of our old-fashioned little scales here. And we work with a system that is in equilibrium. What is equilibrium? Equilibrium is the idea that everything is in a balance. Equilibrium is something that has one end equal to the other end. Let's say I put some weights on my scale on this side. I've added 3. And on this side, I've added 1. I can see that this scale is not in equilibrium. This scale has a heavier part and a lighter part. But let me balance it out equally by having 2 weights on this side and 2 weights on that side, and I will have a beautiful equilibrium because the left-hand side is in fact equal to the right-hand side. So this concept of working over the equal sign is such an important concept because it paves the way for all your algebraic expressions further. Now what I'm going to do is I'm going to write down an expression, but I'm going to insert it into my equation. And I'm going to focus on isolating. Isolating means isolation, quarantining. Let's treat this 2x like the coronavirus. Let's call it the COVID-19. We want to quarantine this. We want to isolate it. How am I going to isolate it in this equation? Firstly, I see a plus 3 here, and I see on my right-hand side a plus 1. What I may do in order to keep this 2x is I may do the opposite of plus 3 by minusing 3. And as my weight that I just explained up here, as my weight needs to show equilibrium, what I took away on my left-hand side, I will have to take away on my right-hand side. But what did I already have on my left-hand side? And what did I already have on my right-hand side? I already had 2x plus 3 is equal to 1. What did I do now? I took away 3. Why 3? Because of the positive 3. And what I did on the left-hand side, I did on the right-hand side. Now, what does that give me? I keep my 2x plus 3 minus 3 gives me 0. And what do I have on my right-hand side? 1 minus 3. And this is why we need to be so careful for what we learned in the first half of our year. We are on a positive 1, but we subtract 3, which means I'm going to the left-hand side of my number line, and I end up with a negative 2. But I'm almost there. I wanted to isolate 2x. I wanted to get 2x on its own. What did I do in the process? This is so important. This that we did right here, this step. This is called transposing. So like the Transvaal River, to transpose, the Buddha trekked across the river, the Vaal River. They went across the river. This is us going across our equal sign, transposing terms, so that we may equate the left-hand side to the right-hand side in order to solve. And then once I have my 2x, which is the quarantined term, the isolated term, once it is equal to minus 2, I need to do the opposite. So there's our next fancy word, inverse operation. Right, inverse means opposite. What is the inverse operation of multiplication? It will be division. What is the inverse operation of division? It will be multiplication. Now let's go back to this 2x right here. What does it mean? 2x is the same as 2 times x. So what would be the opposite of times right here? Surely it will be the division of 2. I don't ever divide by x because I want to solve x. If I divide by x, I'll lose x. But I want to solve for x. So I want to solve for 1x, not 2x or minus 3x. I want a coefficient. the number in front of my variable to be 1. Therefore, I divide by whatever is in front of my variable. But we have that situation called equilibrium. Now we've done something to the right-hand side, to the left-hand side. So now we have to do it to the right-hand side. Exactly that. Division by 2. And what I have now is that 1x, or just x, is equal to a minus divided by a positive is a minus 1. So, as an introduction to our next chapter, we need to understand the importance of working with something called an equation. Something is only called an equation when the equal sign is present. We must, at all times, make sure that whatever I have on my left-hand side is in fact equal to the right-hand side. If I added 3 on my left-hand side, I need to add 3 on my right-hand side. If I subtracted 5 on my left-hand side, I have to subtract 5 on my right-hand side. If I multiplied by 2 on the right-hand side, I have to multiply by 2 on the left-hand side. This process maintains equilibrium, and theoretically, it maintains the integrity of your equation to be true mathematically at all times. Because if I did not apply these rules, I will not get a truthful answer for x, and I'll be incorrect. So backtracking to what we did in the previous chapter is so essential. We must maintain a good understanding of the coefficient, the variable, the exponent, the constant. So what we'll see in our first examples, work examples, are basic investigations of what we think the value might be. This is actually something we've done many times in maths. We've just never called it an equation. When we were in primary school, we would often wonder, Mom has so many eggs in a basket. She adds another 3 eggs. How many eggs did she have in the beginning if now in a basket she has 5 eggs? That was the beginning of algebra. We just never realized it because we didn't call it that. So what we did in grade 3, 4, 5, and 6, we merely suggested this as a little block or a big fat question mark. What add means plus 3 will give me 5. What is this? This is an equation. Why can I make that statement? Because of my equal sign, smack bam in the middle. But I can actually, through inspection, see that that missing value, which I now call x, is going to be 2. Because I can think for myself, but if I have 3 and I want 5, surely I must add 2. This is called through inspection. And it's through inspection that we will validate our answers by applying the theory in solving for x. And that's when we have to bring together all these crucial rules so that we can understand the basis of solving.